The Number System, The Language of Symbols by Miguelito S. Esguera. Every day, all throughout the lifetime, each one makes calculation. By mere aching of the stomach tells us that we have to eat. Baby cries for milk. The egg cells and the sperm cells merge to form life. Our genetic code tells us our ancestry. This and more are examples of computing. So how our numbers come to be? The numeral system, a mathematical foundation. There are certain sets of symbols used by our ancient people, the Egyptians, the Romans, and of course the Hindu-Arabic. The standardized version of symbols that we have today is basically based on the angles it produced. Hindu-Arabic numeral system. We have the 1 with angle 1. We have 2 for 2 angles. We have 3 for the 3 angles. And 4 for the 4 angles. 5 for the 5 angles. 6 for the 6 angle symbol. 7 for the 7 angles symbol. 8 for the 8 angle symbol. 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 for 9 angle symbol, and 0 for none. Now, what is the difference between a number and a numeral? The number is just a concept. It is abstract. It is intangible. So expressing it as a symbol is a numeral. What are the number system? Let us define first what is a number and a system. A number is a mathematical object used to count, measure, or label. A symbol is a group of units working together to meet certain objectives. Based on the two definitions, we can say that it's a group of mathematical concepts used to count, measure, and label anything or anyone. In the context of computer studies, a number system is defined by the base number representations such as 1, 2, 3, to n, but more common are 2, base 4, base 5, base 8, base 10, and base 16. Penta or Quintet number system, or the base 5. On election day, they are most likely used. These are represented like this. Once the person making the tally gets the 5 votes, he would say, Cajon. This number system uses the following numerals: 0, 1, 2, 3, and 4. Set Q has the element 0, has the element 1, has the element 2 up to 4. A number can be written this way: 435 with a subscript 5 to indicate the base. The decimal number system, or the base 10. Commonly used number system. This number system becomes the standard number system used by most part of the world. The decimal system's usage was popular based on assumptions of the 10 fingers we have, which was the primitive symbol of counting. How it is written: 3410 or 3410 base 10. Since it is the human standard number system, it can be written as 3410 without a base. The number system uses the following numerals: 0 to 9. Set Q has the element 0 up to 9. The binary number system, or base 2, becomes popular with the introduction of computers, but early Egyptians used it already in multiplying two numbers known as peasant multiplications, but they are not interested in finding proofs of the procedures. This number system uses the following numerals: 0 and 1. Set Q has the element 0 and the element 1. How to convert decimal number system to a binary number system? The algorithm: Get the number to be converted, name it as n. Divide the number n by 2 and name it m. Get the remainder and write it from left to right, from right to left. Set n is equal to m. Repeat step number 2 until n equal to 0. Converting decimal to binary is continuously dividing it by 2 and getting the remainder until it reaches 0. The remainder notation written from right to left is the binary equivalent written with a subscript of 2. The flowchart. Start. Input n. M is equal to n over 2. Output n modulus of 2. Modulus or mod or modulus is an operation which gets the remainder of a division operation. Now n is equal to m. S is n equal to 0? If the answer is yes, it stops the operation. If the answer is no, it goes back to step number 2 until it reaches 0. Now let us try. Step number 1, get the number. Let n is equal to 20. Step number 2, divide n by 2. Let m is equal to n divided by 2. Since n is equal to 20, 20 divided by 2 is equal to 10. Step number 3, get the remainder. The remainder is 0. Step number 4, set n is equal to m. Since m is equal to 10, therefore n is equal to 10. Now, since step number 5, repeat step number 2 until n is equal to 0. Since n is not equal to 0, it goes back to step number 2. 10 divided by 2 is 5. And the remainder is 0. And since n is equal to m, then n is equal to 5. Then 5 divided by 2, we have 2. The remainder is 1. And n is equal to 2. 2 divided by 1, 2 divided by 2 is equal to 1. The remainder is 0. And n is equal to 1. Since 1 is not equal to 0, we go back to step number 2 again. 1 divided by 2 is equal to 0. And the remainder is 1. And n becomes 0. Since n is equal to 0, we have to stop. We have already the number. Therefore, 20 base 10 is equal to 101,002. Calculator check. Let's try. 20. There we have it. 10100. Okay, converting binary to decimal number. Step 1. Create a place value chart in binary. Get the value in binary. Plot the numbers from the least to the most significant value. Add the place value of the numbers with a value of 1. Step 5. Write the binary value equals to decimal value with a subscript. Binary number base 2 is equal to decimal number base 10. Now, let us apply. Step 1. Create a place value chart in binary. That's it. Step 2. Get the value in binary. There, we have 1010111. Base 2. Plot the numbers from the list of the most significant value. There, it was plotted already. Step 4. Add the place value of the numbers with a value of 1. So, since 2 to the power of 6 and 2 to the power of 4 and 2 to the 2 squared, 2 to the first power and 2 to the 0 power has the 1 value, then we have to add 64 plus 16 plus 4 plus 2 and plus 1. So write the value equals the decimal value with subscript. That's it. So 1010111 base 2 is equal to 87 base 10. Let's do another try. Let B is equal to 8 ones. 1111, 1111 base 2. Now, plot the numbers from the list of the most significant value. There, it's plotted. Add the place value with a value of 1. Since everything is 1, you have to put everything. 128, 64, 32, 16, 8, 4, 2, and 1. Now add all of them and you get 1111 base 2 is equal to 255 base 10. Let's do a calculator check. Okay. I'm sorry for that. But here is the first number, 1010111. Okay, the equivalent number is 87. Okay, let's do another one. 81. There you have it. You have 255. For your assignment, you have to create a video how to get the product value using peasant multiplication. Second, create a Word document that illustrates the table of symbols used in hexadecimal number and indicate how to convert decimal numbers to its hexadecimal equivalent with step-by-step procedures. For reference, we have the following websites and YouTube videos. Thank you very much and good afternoon.